Okay, we start with some information about angles x and y, and we've got to find out all of these other things about x and y. And what we're not allowed to do is think we can find x by an approach that starts with doing an inverse sine of 4/5, because we have to use exact methods. So if we're trying to relate one trig ratio for an angle to other trig ratios, what we can do is pretend the angle's acute and do a little right angle triangle. And acute angles have positive sine, cos and tan. Okay, so if we assume we're just dealing with positives to begin with, then we can actually work out what the correct sign will be afterwards. So if we call this angle x here, and the sine of x is 4/5, we can pretend the opposite is 4, and the hypotenuse is 5. That's the correct ratio, 4/5. And we can work out the third side of the triangle using Pythagoras. So this one squared plus this one squared would be 5 squared. So we do the square root of 5 squared minus 4 squared, which is the square root of 9, which is 3. So it's a 3, 4, 5 triangle. So that would make us think that, for example, that cos of x would be adjacent, which is 3, over hypotenuse, which is 5. But that was all assuming it was a acute angled triangle, an acute angle, so everything would be positive. So we've got to consider whether cos of the angle is positive or negative, and similarly tan of x be opposite over adjacent, which would be 4/3, but this may turn out to be negative. And in fact, we need to know more than the fact that sine x is 4/5 to be able to suss that out. What we actually need to know is that x is obtuse. And I can work out whether cos x and tan x are obtuse angles, should be positive or negative by thinking about the graph of cos x and the graph of tan x. So the graph of tan x looks like this. Okay. And this is 90 here, and this is 180 here if I'm working in degrees, and that's 90 there, and this is 180 there. And in both cases, obtuse means it's between 90 and 180, and in both cases we have negative answers for obtuse answers. So these should both be negative. And I started out by knowing that sine of x equals 4/5. And I can work similarly with angle y. In fact, y is an acute angle, so this really would be an acute angle triangle. And if I want to use my tan of y being opposite over adjacent, that could be 5, that could be 12. Pythagoras says this will be the square root of 12 squared plus 5 squared, which turns out to be exactly 13. So we're going to get sine of y equals opposite over hypotenuse would be 5/13. Is it positive or is it negative? Well, y is acute, so it will be positive, because in the first quadrant between 0 and 90 degrees, cos and tan and also sine, everything is positive for an acute angle. From 0 to 90, they're all positive. So sine of y is 5/13 and cos of y will be 12/13. And I started by knowing that tan of y equals 5/12. So now I have all the raw material that I'm going to need for everything. In fact, part 1 I've already done. Cos of x was the first one we did. It's minus 3/5. Double underline it. 3/5. Double underline it. Okay. For part 2, I want sine of x plus y, but we've just learnt the addition formulae. So this is sine of x. You can use your formula book if you need to look this up, where it's got a and b in the formula book, not x and y. Sine of x cos of y plus cos of x sine of y, but I've got everything I need for that. I've got sine of x is 4/5 times cos of y is 12/13. And then I need plus cos of x, so that's minus 3/5 times sine of y, which is 5/13. So there's a common denominator here already of 65. So this is 48 minus 15, which is 33 over 65, which is the answer we need. And then in part 3, we need to do cos of brackets x minus y. And your formula book tells you that this is cos x cos y plus sine x sine y. So we do those multiplications. So that is going to equal minus 3/5 times 12 13ths plus sine x was 4/5 times cos of y times sine of y was 5/13ths. So again, it's going to be over 65, and we've got minus 36 plus 20, so it's minus 16 over 65. And finally, we've got to do tan of y minus x. So that's tan of y minus x. Well, the formula for that is tan of y minus tan of x over 1 plus tan y tan x. So we've got to do tan y, which was 5/12, minus tan x, that's plus 4/3, all over 1 plus 5/12 times minus 4/3, which my calculator is telling me is 63 over 16. And of course these all should be double underlined to make them clear.